Oh, sorry about that. I'll put her back to sleep. Good evening and welcome to the 904th meeting of the Amateur Telescope Makers of Boston. Tonight's refreshments, I've changed the format, being served by Phil Levine. You did know that, right, Phil? Okay, well, go to McDonald's and get us some good food. Our speaker this month is Peter Scherff, Meteorite Man, and he's been selling meteors over there. He will be available after the talk, too, if anybody wants to pick up some samples. I got one of the Chelyabinsk, okay. Next month, heads up, we're going to have Rich Nugent talk about observing satellites. He'll be our speaker for next month. Yay. And we're going to start with Phil with the Treasurer's Report.
Secretary's Report.
This is a summary of the November 9, 2017 ATMoB meeting held here at the Smithsonian Center for Astrophysics. Club President Glenn Chappell called the meeting to order at 8 p.m. Eileen Myers distributed the Royal Astronomical Society of Canada Observer's Handbook. This year there was an American version for the first time. And Astronomy 2018 calendars for members who ordered copies. Phil Levine read the Secretary's report. Eileen Myers presented the Treasurer's report. Chris Elledge presented the membership report. Glenn Chappell presented the Observing Committee report. Steve Clougherty presented the Clubhouse report. New business at the next ATMoB board meeting, the topic of establishing an ATMoB club pin or re-establishing an ATMoB club pin will be discussed. Announcements. Ed Loss informed the membership Allison Doan, former curator of the Harvard Astronomical Glass Plate Collection, passed away October 29th. The guest speakers for the evening were Jean Laveau and Tom Lepisto. The presentation was entitled Howard Laveau in Antarctica. Howard took part as an auroral for the that's a tricky word, physicist in an expedition to Antarctica as part of the scientific team during the International Geophysical Year 1957-1958. Some of the scientific equipment used to study the auroral astralis for Australia included, what's the right pronunciation? Australis, thank you, Dick. Included all-sky cameras and radar setups. Gene and Tom showed photos of Howard and expedition members, also detailing the snowy, barren landscape. Living conditions were primitive and basic. For more details about the meeting, please refer to the December Starfield newsletter. Glenn Chappell adjourned the meeting at 9:10 p.m.
Vocabulary lesson tonight, Australis and Chelyabinsk. Observing Committee report. And a bunch of events coming up in the next month before our next meeting. Right now, the Geminids they actually probably passed peak last night, but there still should be some left over. So when you get home tonight, if it's clear, I don't know what the weather forecast is for, but you might catch a few of them. Anybody see any last night? I was out, I was looking at Phaethon, we were Phaethon, which I'll get to in just a little bit. But every now and then, between observing that asteroid, I'd check it a few minutes or so. And I was only out for about 45 minutes. It was cold out there, but I probably saw about 8 or 9 meteors, and most of them were, I would say, just as bright as Venus. I looked like they were negative magnitude meteors. They're very striking. Anyway, that's a possibility. Get home and it's clear. Give it a check. On Saturday, December 30th, the moon's going to occult the star Aldebaran. It's on from 6:27 to 7:22, and these are posted on our website, by the way, under the different events coming up. January 7th, Jupiter and Mars are going to be almost touching each other, just 0.2 of a degree apart in the morning sky. And that following Thursday, January 11th, which is the date of our next meeting, in the morning, crescent moon will join us. There'll be a nice sight in the sky at that particular point. I mentioned Phaethon, I guess that's how you pronounce it. We got Australis, Chelyabinsk, and Phaethon. And this is a sketch I made last night. I went out, for years, I've been tracking down asteroids with a little 3-inch Edmund telescope that I have. I want to see how many I could catch with that little scope. And it's over 100 now, but it gets harder and harder because I've always picked up all the bright ones. And this is kind of a rare opportunity. Some of these near-Earth asteroids, the so-called near-Earth, they rarely make a close pass, and that's what happened with Phaethon last night and tonight. It's still pretty close. But I went out, here's a star, 30 Persei. This is a 1-degree field, and I started at about 8:50, and I made observations about every 10 minutes. And I just put little arrows to where they show, so you could definitely see the motion of this object in a very short period of time. I had to stop here because my eyepiece froze. It just iced over. I couldn't see anything at all. So I was glad I saw what I could see. And what's that?
Stop prying into the eyepiece.
Yes, we're going to do a switch now because Rich has a couple things to say about this.
So there's still time to see this object if you're interested. And I'm going to spend just a couple of minutes. One of the greatest resources around is the Sky and Telescope website. And they've got some beautiful star charts to help you find this almost 11th magnitude asteroid. It's faint. That's faint. And nothing beats knowing where it's going to be. And I know it's cold out. I was out for about 45 minutes, about an hour actually, a little over an hour. And the reason my observation stopped was because with the Dobsonian, you know there's Dobson's hole, right? Straight overhead. That when the telescope hit the mount and couldn't go anymore, I was going to roll it through and continue to follow it, but enough. You couldn't see it drifting through the star field in real time unless you looked at patterns, linear alignments of stars, triangles, to see how things deformed out. And it took me a few trips back to the computer to a star chart that's considerably deeper than this before I actually was able to identify which little tiny faint star was it. Because it's not zipping through the eyepiece field of view, you have to be patient. If you're going to go out there and try and find this tonight, it's supposed to be cloudy tomorrow night, but clear on Saturday night, come up to the clubhouse. John Reed and I are on duty. And I'll have the scope and we'll put it in the telescope where you can see it for yourselves. It won't be zipping through the star fields. But the one technique I wanted to share with you tonight was it's always important to, if you want to go out and see these things, is to head them off at the pass. Yep. And that's the best way I know to do this sort of thing. And so what I did was I made a copy of this star chart, which is beautiful. It's paralleling Andromeda tonight and tomorrow night. By Saturday night here, 7 o'clock on Saturday night, it'll be down here. So it's in a really easy part of the sky to find. I always look for star patterns. Now, Al, help me to get to the next slide. There we go. So I zoomed in on just a section of that last chart. And is this the red pointer?
Pushing the center.
Push the center thing, this thing here?
The center. The other side.
Oh, that. So so here's 7 o'clock on tomorrow night. Here's 11 o'clock tomorrow night. And so there's a nice little window of time. You know, it's not too late. Notice that the path carries it through this little asterism here. Just a group of stars near Merak, which is Beta Andromeda. And so this little loop of stars, this little triangle here, kind of gets you down into this region here. And I would go to these, just between 10:30 and 11, it's going to pass by that star right there. And that's what heading off at the pass is all about. Yeah. So if you're interested in doing it, I know tomorrow night it might be cloudy, but the next night we'll do the same thing at the clubhouse. We'll head it off at the pass. We'll go to where we know it's going to be at a certain time, and we'll pick it up like that. And that's what I would encourage you guys to do. If it's too cold for this one, we'll catch the next one. Don't worry, because it's really cold outside. It does take some experience. But I would encourage you to get out and observe as often as possible and to get that experience. And like I said, on Saturday it should be clear. We'll be up at the clubhouse, and you should come on up and check it out. It's pretty good.
When's the next passage? It's in 30 years, so we'll all be ready to go.
Well, this is an article Bob King wrote for Sky and Telescope's website. And when you read that article, he mentions that the next favorable pass in Phaethon won't be until 2093. Oh. So I'm gonna probably see it now. It's a long time off. And so, we're not gonna get a chance to see this one as bright again. But they're fun to watch. They're just fun to get out there and just something else to do. Thank you, Al. Thank you, Glenn. All right.
One. According to the Royal Astronomical Society of Canada calendar, Sunday, January 7th. That morning, we should be able to follow Arcturus unaided into daylight Sunday morning. So that would be fun
All right.
to see Arcturus during the day.
What is it going to be? How are you going to be able to see it in the daytime? It's going to be near the moon?
I don't know.
They say follow it into the daylight.
Yeah, follow it, to find it and follow it into the
Oh.
Use a planisphere.
I know I've seen people that do that with the North Star. They'll send it in the eyepiece field, and hopefully it'll still be there sometime during daylight. Yeah, Rich was mentioning the ambush thing, and that's what I did here. I did my own chart. I went to the Minor Planet Center and got the ephemeris for the asteroid, which was pretty much in agreement with the Sky and Tell one, but it labeled more stars from the Millennium Atlas did, so I used that. And that's what I did. I went right to 30 Persei, and I saw this little group right here, which is a triangle. And when I first set up on 30 Persei, I saw this would look like a double star. So I wasn't sure which one was the asteroid, but then I noticed this one moving. That's why it's a little bit off compared to the other ones. But you can see it move across that triangle over to this area. And again, I was also having the same problem that Rich talked about, where you get the Dobsonians ready to hit the mount. So I probably wouldn't have been able to make much more than another 1 or 2 observations anyway. But it'll be out there again. It should be visible tonight if anybody can get the Sky and Tell chart and you're not too cold. All right. Our objects, the December 2017 Observers Challenge is the Galaxy NGC 925. I believe that's one of your pictures, right, Mario? And it's about 10th magnitude, but it's a fairly large galaxy. I've heard people are already having kind of a hard time seeing this. So I guess the key is, the challenge is, can you see it at all? Yes?
Through the 32, all you see is the core.
Yeah.
So,
Well, you've kind of spoiled it for us now. We have these puny little 12-inch telescopes, that you use for finderscope. The Sioux French Fan Club. This is a favorite of mine, and it's Star Parties. The kids love this one. It's the ET cluster, NGC 457. It's right there. And that's near the star Phi. In fact, Phi is right here. It's a wide, naked eye double star, or at least a binocular double star. But I've done this at star parties, and the kids, they all know who ET is, and it's amazing. They'll see right away, there are the eyes, and you see these arms, and it's showing down here as well. The only thing I disagree is I always thought of these as the feet. They have them up here someplace, but I kind of like to extend this out here, although I think the main cluster is this group right here, and these stars are just extra. But it's a really neat object for star parties, so give that a look-see sometime. It's a lot of fun. Use low power because it's a very large cluster, but it's easily seen in small telescopes. Member picks. Maria Batista stepped to the plate. And by the way, you're all welcome to send me any objects you'd like me to feature at our observing committee report. Just send something in. If there's somebody who's already picked that month, we can always slide it to the next month, and things will still be visible. So please do send something. I can't remember now who's got next month. I think somebody picked up January's. Rich? Okay. Anyway, she picked 2, M81 and M82. And I want to point out again, I think some beginners are a little bit nervous about suggesting something to this room full of all these expert observers, but it's nice to go back and check some of these things out. And what I like about these 2 is they're very nicely seen with a small telescope. You can catch them in the same field. And I don't like doing galaxies at star parties. You know, Andromeda Galaxy throws us. John Q. Public could care less. They think somebody breathed on the eyepiece. Seriously, they just don't wow people. But you get these 2 in there, and there's a definite difference. They see this circular blob, and then they see this cigar-shaped thing, and it really does get their interest. So that's a good target for a star party this time of year. It's right on into the spring. Anybody have any questions, comments, or anything about observing? Okay, as always, keep looking up. Steve, we have a Clubhouse report.
I plan on being there Saturday as well, so I'd be happy to show people that those images in my 18. It's snow season. Winter has begun. So we had one little glitch at the clubhouse. The contractor who worked for MIT no longer works for MIT. His name is Wayne Legacy. I talked to him on Monday, and he agreed to continue plowing us for this year. He's charging us what he charged us last year, which is $100 after each snowstorm. And he'll do our driveway and our parking area, which is what we've had done for the past couple of years. I think our budget's about $500 for the year for the snow budget. And last year it was a little bit under because we had a pretty merciful season. This year, who knows? But I think that's very reasonable, and he agreed to stay on with us. So hopefully he won't decide to retire and move to Florida. We had, on the 2nd, 2 weeks ago, we had 17 volunteers at the Clubhouse. We want to thank Dave Prouton for repairing a broken window on the 2nd floor above the bulkhead. He also added a storm window, which was very nice. And outside work was done too. It was mild enough so that Bill Toomey, Barry Jansen, and Joseph Rothschild did some scraping and staining on the clubhouse just beyond the porch, which was great. It really looks very nice. I have a note here that Maria Batista actually scraped and painted the 2nd floor hallway ceiling, and I want to know how she did that. Because I thought about that last year and I couldn't figure out how to reach it. How did it work?
Well, I took some duct tape, attached the scraper to my painting stick, scraped it. Well, I had to do it twice because the first time I only sanded it and then the paint started coming off. So I had to scrape, wipe it clean, and then I just attached the paint roller to my extension.
Now see, that never occurred to me.
After all
You're
these
hired. You're staying. Okay. And we had Ken Stevens, he cleaned the 2 sinks downstairs in the grinding room and the polishing room. John Marr fabricated a counterweight system for the Meade 16-inch telescope, which incidentally works very well. We hope John can come out on Saturday and operate it. We're planning on purchasing an upgrade for the focuser in the next couple of months for that, which should complete the project. John kindly donated the new Meade dew shield for that telescope. We thank John for that. And let's see, again, thanks to the lunch and cleanup crew, Eileen Myers, Sai Valava, Al Takeda, Eric Johansson. And our next work party will be on the 30th, 2 weeks from this Saturday, with the New Year's Eve prep. Respectfully submitted.
Announcements. We have a very special announcement to start with. I'd like to introduce Stella Kafka, who's the director of AAVSO, and she has a presentation to make.
Yes.
The floor is yours.
All right. So good evening, everyone. Actually, it's a great pleasure to be here at the American Association of Variable Star Observers. Can I have that?
Yes.
Can you hear me? Can you hear me?
Yes.
Can you hear me now? Oh,
Yes.
you can hear me now. Excellent. So at the AAVSO, we give awards to our observers recognizing contributions, their contributions to our database, the variable star observations that they make, all the hard work and effort that they actually put into taking data and contributing to cutting-edge science. At the same time, though, we also have awards that recognize contributions of members with a wider impact to the community. And one of those awards is the William Tyler Olcott Distinguished Service Award that is given to outstanding contributions promoting variable star astronomy. This year, the award was given to Mario Motta. This is an award that is decided by the AVSO Council. It was decided in June and actually was presented in front of membership in November 4th, actually, in our annual meeting in Nashville, Tennessee. But Mario cheated us and he was in Hawaii, really. So it's wonderful that I have the opportunity to re-award the award to Mario today in front of his third family, I guess, after the AVSO and his real family. Actually, I would like to read the citation that we have for Mario to you and give him the award again. So it is an honor and privilege to present the Olcott Award to our colleague and friend, Dr. Mario Motta, As a practicing cardiologist, Mario is dedicated to fixing and preventing future damage to the hearts of the citizens of the greater Boston area. But equally important to Mario is fixing and preventing future damage to our night skies. Through his tireless work on the adoption of local lighting ordinances and best practices in the Gloucester community, his home state of Massachusetts, and the nation at large, as well as his service to the New England Light Pollution Advisory Group and the International Dark Sky Association, Mario has made a significant contribution to variable star observing by protecting our most important resource, our night skies. It is fitting that the Northeast region of the Astronomical League, which presented Mario with their highest honor, the Walter Scott Houston Award, refers to him as the light pollution warrior. You need a cape. In a masterful synergy between his vocation and avocation, Mario has been an indefatigable voice, bringing the health effects of light pollution to the forefront of scientific discussions at the August American Medical Association. The unanimous passage of AMA Resolution 516 in 2009, which supports efforts to control light pollution, and the acceptance of the 2016 report of the AMA Council on Science and Public Health that sounded the alarm on the harmful human environmental effects of LED light, are both largely due to Mario's tireless efforts. But Mario's contribution to variable star astronomy go well beyond preserving our night skies. Mario is also dedicated to introducing new generations to the rewards of amateur astronomy. Through his work with the Amateur Telescope Makers of Boston, the Springfield Telescope Makers, and the AAVSO, as well as countless hours as an individual, Mario has shared the joys of observing and astrophotography with myriad community and school groups, members of the media, and budding backyard observers of all ages, yours truly included. In recognition of his work, he was a very deserving recipient of the 2003 recipient of the Astronomical Society of the Pacific's Las Cumbres Amateur Outreach Award. While Mario has served the AAVSO in more traditional ways, for example, as a council member from 1996 to 2000 and president from 2011 to 2013, it is his quiet, unassuming work behind the scenes that is perhaps less widely known, but no less important. He was recruited into the AAVSO by Janet Matty in 1985, not longer after completing his medical residency, and was always one of Janet's go-to people. He was a driving force behind the AAVSO's partnership in astronomy program in the early 1990s that brought variable star astronomy to the Boston area school and built 6-inch telescopes, including grading the mirrors, with fifth grade students, a task only slightly less difficult but arguably as significant as the construction of this 32-inch telescope and observatory, complete with building house. Mario Mota has an infectious enthusiasm for observing the night sky, and an equal passion for preserving its natural beauty, and an equal dedication for sharing his experiences with others in the hopes that they too will come to love the stars as much as he does. It is thus fitting that we honor him this evening and present him with the AVSO William Tyler Olcott Distinguished Service Award. So Mario. Thank you very much for everything you've done, everything you're doing. All right, and for actually being my personal friend as well, and advisor, so a pleasure.
Thank you.
Far in my observing control room. Thank you. That's overdone, but I think you reached the age where they've run out of people to give awards to, so I'm definitely getting old. Thank you. I do cherish this. I thank the AVSO, and it's my pleasure to work with them. Thank you very much.
It's an honor for us as well. Thank you.
Okay. Well deserved.
Well deserved.
Oh, we'll back it up. We've still got Phil's going to talk about a book that he wants to recommend to the club. I guess you're going to put it on the back table if anyone wants to look at it. But I'll let you.
Yeah. How about if I put it by the Pelican right up here?
All right.
I do a lot of my observing with binoculars, and I'm getting a little older, and I have a lot of floaters, and I think a lot of us may have the same issue. So 2 eyes are better than one, and this book just came out, and it gives a lot of helpful hints on what to look for in a good binocular. Also goes into some repair work, collimation tools, and it's a pretty good read. And if you want to Google the author, his name is William J. Cook. He was the chief optical man in the U.S. Navy. He's retired now. He actually has a number of publications out. So if you look on LinkedIn, he has quite an extensive optical resume. So I'll leave the book here if you want to look through it.
Hey, thanks. And we have got a request to have a Clubhouse visit, and Chris wanted to talk a little bit about that. It's from the Groton Community Center. We're looking apparently for a volunteer to help out.
Yeah, I'll go ahead and bring it up real quick. It's Tim Leonard at the Community Center. He did a program last year at the library, but he said that one of the big complaints he got was that they didn't actually go out and look at stars. So he's very interested in having a field trip for the class to our observing field. He's looking for somebody who would be able to help him basically point at things in the sky. But what he said, he's looking for anybody who's capable of doing a 1 hour, star show or mini star party for the class, all the way up to somebody who'd be interested in being a co-teacher with them. There would be 2 different sessions this spring. There would be a session from March 5th to April 13th, and a session from April 16th to May 25th. That's 6 weeks, 1 class a week. He's able to pick from any weekday, and they have a bunch of different time slots, so you can work with him if you're interested in being a co-teacher. And so if anybody who's interested in helping him out, just talk to either Glenn or I, or email us, and we'll help get him set up.
What age group is it?
I don't actually know. Since it's a community center, it's usually anywhere from young adults and elderly. So, while I'm up here, I want to make another announcement. I was asked to make a DVD of our ATMoB presents the Great American Eclipse, total solar eclipse. So I have taken the presentation, just the presentation portion of our meeting from September, and I've made a DVD of that. So, and anybody who's interested in having a copy, I would ask for just $1 to cover materials. And I'm going to put a sign-up list in the back, and so I can get a sense for how many I should make.
Nice, thank you.
I would.
Who wants to talk about the New Year's Eve party?
New Year's Eve party will be New Year's Eve. It's a Sunday night. We start at 7 and we go on and on and on and on till 1 in the morning. We celebrate every hour on the hour. We blow noisemakers and we have a little drink of something or other, depending on what your preferences are. And you can come as you are. We have some funny hats and beads and stuff that you can put on and make it very festive. We have a lot of decorations. So if you come to the work party Saturday, we can spruce the place up a little bit, which I think it looks pretty good now, and hang all the decorations all over the place. It is totally transformed. You wouldn't believe it was the Clubhouse at the New Year's Eve party. So please come and help. Bring food for the New Year's Eve party. You can bring anything you like, an entree, a dessert, an appetizer, and come whenever you want, leave whenever you want. It's very open.
Thank you.
That's at Clubhouse.
At the Clubhouse. Yes, at the Clubhouse in Westford.
By the way, the red was for emphasis. It wasn't symbolic of the bloodletting that happens at midnight. Just an announcement, I'll mention this next time too. We're gonna have a board meeting just to kind of touch base on the different issues we might have going. It'll be January 18th, 7 o'clock at the Clubhouse. I'll be putting something out next month, and we'll be looking at any issues you'd like to have us cover at this board meeting. We're already talking about possibly really putting together our outreach program. I remember Mike, and I forgot his last name, does Popscope. He's been kind of sending things out. We haven't really touched base with him, so I'd like to get him officially in the group. Virginia, of course, with the star parties, and possibly even something with the telescope library loaner program, to try to put these all together. So there are a couple of things we've had that we're thinking of. Does anybody else have any announcements? Yes, Eileen.
I don't know if you know about the Jewish religion, but the Sabbath ends by looking for 3 stars in the sky. And the synagogue that I belong to is going to have a star party on January 6th. It's a Saturday night. And the kids will look for 3 stars in the sky, and then they'll light a candle and that sort of thing. And then we'd like them to look through telescopes. Now, they're young. It's the 2nd, 3rd, and 4th grades. About 37 kids, plus parents, siblings, grandparents, that sort of thing. And they're young, so stars of different colors are really good to show them. There aren't many planets. The moon won't be up, so lots of stars. So we can use help.
Okay,
And
where's
if
it going to
anyone
be?
wants, it'll be at the synagogue in Acton. It's called Congregation Beth Elohim in Acton. It's a very active synagogue socially too. They help lots of immigrants. They do help all kinds of things. They're do-gooders.
So will there be something on ATMoB announced?
Yeah,
Okay.
they're just finalizing this stuff right now.
All right. Thank you. Anything else? Yes, John.
Just for reference, today is Tycho Brahe's birthday.
How old would he be if he was still alive? That's still the greatest line. Any old business you want to be brought up?
Wasn't that?
That's probably yes.
I'm still looking for
Oh, yeah.
Dick, I think his last name is Coyne, for a handbook. He reserved a handbook. And Charles D'Amico. Does anyone know them? If you're listening.
Maybe they'll see it on the internet. New business. Yes, John.
We got another shipment of the patches from the eclipse last August from Missouri. 50 of them just came in, so those who wanted to get them when we sold out, they're at cost, $6 a patch. They're NASA quality. 2 astronauts who retired are teaching at the University of Missouri, and they help the club down there design and find the people to make the patch. So they're available here and at the Clubhouse.
Thank you.
Frame them at the stand.
What happens if people only saw the partial eclipse? Do we get like a half patch? By the way, talking back about the board meeting, that somebody mentioned a pin, and I think that's a great idea, just put on a hat or something like that. So we'll look into that as well at the board meeting. I know when I asked last time, a lot of you raised your hands, said you'd be interested in having a ATMoB pin. Okay, tonight's guest speaker tonight is Peter Scherff, who's going to talk about meteors. He's been selling them, and he will be available after the talk to sell some more if anybody's interested. And I guess while Al is setting them up, I'm going to read a biography. So we'll do a little switch here. All right, this is off our newsletter. Peter Scherff first started working with meteorites in the 1970s when he used meteorites to create out-of-this-world jewelry. Working this amazing material piqued his interest, and he started studying meteorites to learn the science behind them. His studies have continued to this day. He prepares meteorites for study and or display, makes thin sections for study, and etches iron meteorites to display their beautiful qualities. He has worked designing museum displays, selling and providing meteorites to both the public, universities, museums, as well as private collectors. He has also traveled the world hunting for extraterrestrial rocks. Peter's a member of the Meteoritical Society, the International Meteorite Collectors Organization, as well as local and many national astronomy associations. So I'll introduce you, Peter Scherff. Thank you very much for coming.
Thank you. Thanks for having me.
that way you have to share. Yeah. I wanted a souvenir. Here we go.
All right, Meteorites 101. What they are, where they come from, and how we find them. First, a few definitions. As you would know from talking about the Perseids, meteors are these fireballs, or I'm sorry, Geminids. Meteors are these fireballs we see in the sky. And most meteors are relatively small. They are about the size of the fingernail on your pinky, and they have the consistency of cigar ash. And those are those bright, first -1 magnitude meteors, shooting stars we see. Next are fireballs. These get exciting, but not big enough for me, thank you. Boloids. These are the things that drop rocks. These are what I live for. When they happen, my wife and I like to get on a plane, in a car, whatever, and go hunting for them. In space, rocks are divided into meteoroids and asteroids. A meteoroid is anything under 10 meters. Asteroid is anything over 10 meters, but not big enough to be a planetesimal. In reality, anything big enough to be seen from Earth is going to get called an asteroid. Meteorites are the leftover junk from the formation of the solar system. And by looking at a pile of leftover junk, you have a pretty good idea of what the solar system is. You can see, from this pile of debris, oh yeah, 2x4s, some insulation, some metal there. You can go, oh, brick there. You can learn what things are made out of. And that's what we do with meteorites, is we take a look at them and see parts of the solar system, or even parts of Earth, that we wouldn't be able to study firsthand. Asteroids live in neighborhoods. Most asteroids are in the main asteroid belt. The ones that are exciting are the ones that come and cross Earth's orbit. There's about 100 tons of extraterrestrial material that falls on Earth each day. And of this 100 tons, most of it is what we call meteoritic. It's dust, small rocks, whatever. But of that 100 tons, not a lot is found. Most years, about 100 pounds of freshly fallen meteorites are collected. So 100 tons, that weight of a battleship falls, and we find the weight of one Sasha Obama every year. Yeah, they're hard to find. Most of them fall in the water or burn up, but by far most of it is fine dust. My wife complains about dust in her house. I tell her that is part of the cosmos that's landed here on Earth. She hasn't bought that yet, but it's the truth. Some of the cosmic debris that hits the Earth is from supernovas. Like this one, I'm sure a lot of you have heard about supernova 1987A. The Crab Nebula is probably the most picturesque supernova remnant. But when a supernova goes off, it forges elements that are only made in supernovas. And they eventually land here. These are manganese nodules on the seafloor. And these manganese nodules are iron rich. They contain iron 60 that was forged inside a supernova. And there was one that went off, maybe a million years or so ago. And we can find remnants of that by looking at the ocean floor. New place for astronomers to go. And this is the inside of the manganese nodule. And they actually grow almost like tree rings. So the center will be the oldest part, and they just keep accreting and forming. And you can cut them open and then go and say, oh, right there, there's this iron 60 that only forms in a supernova. So you know one went off near us. But as I said, most of the stuff that happens here is from meteorites. And many people will tell you there's 3 types of meteorites. They're wrong. There's 2 basic types, differentiated and undifferentiated. What happens when small asteroids or meteoroids form is the rocks accrete, dust particles, small chondrules. They stick together, first by static electricity, then by gravity. Eventually enough stuff sticks together that the body starts to melt. There's decay of radioactive isotopes, and they heat up the rock. And if it's big enough, there's enough insulating blanket so that rock will melt. And as it melts, the heavy parts go to the center, and then the lighter parts float to the surface. So we have nickel-iron cores of differentiated bodies in silica crusts. There are smaller bodies, which are the common chondrites, where it hasn't gotten hot enough to melt. They might have gotten a little mushy, whatever, but they didn't melt and differentiate. So these rocks will have their iron still present in them, whereas from a larger body, the surface is iron depleted, the core is almost pure iron. Not all meteorites contain stuff forged in this solar system. Some meteorites, including the Allende that fell in 1969, contain pieces of material that is unaltered from before the solar system was formed. This meteorite, the Allende one, had good luck to fall in 1969. I don't know if any of you were around then, but what was going on in 1969?
Apollo launch.
Apollo launch, exactly. And, you know, Apollo was great about rockets and all that exciting things, but the science of Apollo was done in a large part at this thing called the Lunar Receiving Lab. And here's Dr. King in the lab, and they built the best place to study materials from outer space. And it was great, except in the beginning of 1969, we didn't have any samples back from Apollo, so they had to figure out some way to test it. The Allende meteorite fell early that year in Mexico. It was the perfect opportunity to do a dry run on a rare type of carbonaceous meteorite. So they studied it, found nanodiamonds. This is, I don't know, probably similar in size to this. And it was done, those diamonds were collected by melting a rock about the size of the Allende sample I have over on the desk, maybe 5 kilos. And these diamonds were formed from the sun a generation before ours. And they are unaltered since then. Allende meteorite is also famous for these little amoeba-like blobs. They're calcium aluminum inclusions. They are some of the earliest remnants of our solar nebula. And our understanding of meteorites is continuing. Not only did the Lunar Receiving Lab give us a great deal of knowledge, but we're still studying the Allende meteorite today. And just earlier this year, a new mineral was found, rubinite, named after Dr. Alan Rubin from UCLA, and it's a type of garnet. So never before found, seen on Earth. It was discovered in a meteorite this year. Meteorites interacting with the Earth has always been an interesting thing. In 1891, Dr. Gilbert had a theory about this hole in the world in Arizona. We call it was called Coon Butte then, and it was this cryptovolcanic structure. Apparently, magma from the Earth had moved up near to the surface, hit groundwater. The groundwater somehow flashed to steam, caused an explosion, and made this hole in the Earth. And sometime after that hole was made, a meteorite landed, sprinkling the whole area around that hole, but very little in the hole, almost all of it around the hole, with iron meteorites. We sort of are all laughing at that nowadays, but no one had any idea of the force and power that an asteroid or a large meteorite impact could have. This guy sort of thought about it. Daniel Barringer saw that and said, no. Those meteorites aren't there by coincidence. They had to have caused that hole. And you know what? A piece of iron big enough to make a hole that big is valuable. He thought it was worth what today would be $1 billion. So he invested his money, and he was a wealthy man, made his money in silver mining, had $15 million that he sunk into what we now call Meteor Crater, and he was looking for that big lump of iron in the bottom. What he didn't realize was when an asteroid hits with that much speed, with that much mass, it vaporizes on impact. It does not punch a hole and sit at the bottom of the crater. So that meteorite vaporized. And when I was young, I always thought when something was vaporized, it was gone, it vanished. I had seen enough laser shootouts in science fiction movies that I knew when something vaporized, it's gone, no more. But that's not what happens, of course. We all now know and are giggling that when something vaporizes, it just means it's turned into vapor. And what happens to vapor when it cools off? Anyone? Condenses, exactly. So that meteorite vaporized, was blown up into the atmosphere as this vapor, condensed, and then rained down for maybe 20 miles around the crater. This gentleman, Harvey Neininger, realized that, and it wasn't any great scientific theory that taught him that. What he did was he noticed there's these little small grains of iron all around this crater. What are they from? How did they get here? And so he and his son took a huge generator, put it on the back of this, whatever jalopy you want to call it, and used it to power these electromagnets. And they drove around the meteor crater collecting the iron rain that fell. And that's where most, if not, well, over 90% of the meteorite turned into this iron rain. Widmanstatten patterns. These are the crystalline structure that you can see here that happens inside an iron meteorite. The Widmanstatten pattern takes maybe 1 million years to form, so it's nothing that we can recreate here on the surface, but this is what the material of the core of the Earth looks like. If you ever took a journey to the center of the Earth, you would be traveling through liquid iron and nickel. In this case, some fool's gold. Canyon Diablo is an interesting meteorite in that instead of being almost pure nickel iron, there's a lot of graphite. And the graphite is distributed in little pockets, balls, bubbles, whatever, of this graphite. And anyone know what happens to graphite when it's subjected to heat and pressure like would happen when a meteorite hits the Earth? You got it. So when the meteorite hit, if there was a graphite pocket, that pocket of graphite would be turned instantly into a diamond. So a different way of forming diamonds than most people think of. Next rock I'm going to talk about is related to the Comet Drive-In. This is a drive-in in Sylacauga, Alabama, and across the street lived a woman, Ann Hodge. She was taking a nap one afternoon in her house when a rock fell through the roof of her house, through the ceiling, hit the floor, bounced off the floor, hit her radio, bounced off the radio, and then kissed her right there. She's the first person to ever have been documented to have ever been injured by a meteorite fall. And Ann Hodge became famous. She was in Life magazine. She was on a TV show called I've Got a Secret. You can guess what her secret was. And she knew that she was going to make a fortune off of this meteorite that landed in her home. There's the rock, the hole the rock made, and there's the meteorite. Not very big, lucky for her. And by the way, for some reason, when people in America have a meteorite hit their house, they call the police. Sometimes the police take the rock, sometimes they don't, but it's like invariably the police get involved. Don't know why, but as far as I've seen, there are no laws against it. Anyway, she was going to sell this rock. Here she is in front of her home, holding the said rock. However, there's a law in this country, or actually not a law, precedent, that the meteorite belongs to the property owner. She rented her house, and her landlord had to pay to fix the hole in the roof. Her landlord wanted the rock back, and it ended up in court, and eventually they settled, and Ann was able to buy the rock from her landlord for $500. Unfortunately, though, by the time this got settled, Ann's 15 minutes of fame had faded, and she wasn't able to sell the rock. No one was interested in it anymore. There were hundreds of people trying to buy it from her when it first fell, and she didn't own it. But as soon as she owned it, no one was coming around with the money. Eventually, what happened? She was able to donate the rock to the Alabama Museum of Natural History, and they gave her a $500 honorarium. So she broke even after spending years trying to peddle her rock. So this was sort of unlucky for her. It actually put a strain on her marriage, perhaps causing the divorce. Don't know. But most people don't know that there was a second rock that fell that day in Alabama. And this second rock was found by a farmer. He was driving his mule to his field, and his mule balked, would not go down the road. Farmer went and looked and found that there was this rock in the middle of the road that was scaring the mule. So the guy, like any intelligent gentleman would do, went and kicked the rock into the gully beside the road, continued on to do his work. Came back home, heard about Ann Hodge and getting hit by a meteorite, and realized that's what he saw, was a meteorite. That's a cool thing. He went back, he was lucky enough to find it, and here he is. You can barely see the rock in his hands there. But Julius was able to recover the rock. And Julius, being a poor black farmer in Alabama, is one of the few people who did not call the police when he found his rock. Instead of calling the police, he did something that just amazes me to this day, he called his mailman. A part of the federal government, someone who he knew and trusted, and his mailman brokered a deal with the Smithsonian Institution, and Julius sold his rock to the Smithsonian for enough money to buy his house, buy a truck so he didn't have to be using the mule, and set his family up quite well. So he was much, much luckier than Anne, and no one ever talks about Julius. He's just totally forgotten in this story. October 9th, 1992, Friday night in the United States in the fall. What happens every Friday night in the United States in the fall? Exactly. And fortunately, in 1992, there was this amazing new invention, the portable video camera. You could actually hold something in your hand that could take movies. It was like, I don't know if any of you have ever seen a device that you can hold in your hands that can take movies, but they were very popular back then. And because of this, this new invention, there were people all over, up and down the East Coast, filming their son's football game. And during the football game, there was this bright meteor. 16 different video cameras captured this at 16 different football games. But because of all these videos, they were able to determine the orbit of this meteorite. Traced it back, and as usual, it's a main belt object, so not too exciting, but pretty cool still that we have so many videos of it. Anyway, this fireball was seen up and down the East Coast Friday evening, and eventually it dropped a rock right here in Peekskill, New York, through the trunk of Michelle's car. And Michelle, being a woman from a white woman from the United States, called the police. The police came, and they determined that yes, her car had been vandalized, and they would try to find the person who threw the rock through the trunk of her car. Needless to say, it wasn't a person that should throw that rock at 300 miles an hour, which is the terminal velocity of most meteorites. Here's the car. The rock. It's slightly bigger than a football, and you can see the red paint from its passage through the trunk. Michelle managed to file a claim for her car. The insurance company denied it. Fortunately for her, because she ended up selling the car and the meteorite for close to $50,000. So her $500 car turned out to be a good investment for her. Another way people find meteorites is in the desert. Now, Anton Saint-Exupéry, anyone know who he is?
Little Prince.
You're right, he's the guy who wrote The Little Prince. But before he became famous as an author, he was a mail pilot in northern Africa. And back then, when you were flying, a large part of it was learning how to survive crashes. He crashed, I think, 5 times in his career. And one time when he was walking to the nearest town from his crash, he was on this huge sand dune. So tall, he was certain that no one had ever been to the top of that sand dune before. And while he was up there, he saw these black rocks. And it's like, what are black rocks doing in the middle of this field of sand? And then it struck him that if you want to catch apples, you spread a sheet underneath an apple tree, and the apples will fall on the sheet. And what he had discovered was a sheet of sand spread under the heavens, and they were catching falling stars. And he wrote about his experience in his memoir, and everyone went, wow, that's very poetic, and no one did anything about it. Until the 1990s. And then a bunch of Frenchmen, surprise, surprise, since he wrote in French, read it and said, we can go find those rocks. And they did. They went to the Sahara and they started finding meteorites all over the place. Before this gold rush in the Sahara, I was a meteorite collector back then, and a new meteorite would come to the market, we would all go crazy. There'd be, a rock this size, and all 100 of us in the world who collected meteorites back then would want a piece of it, and we would fight over it, and we'd get a chance to find one of those a year, maybe, in our collection. Once these things started turning up in the desert and people learned how to find them, there were thousands of rocks being found every month. It was just totally amazing. The number of known meteorites in 1990 was probably less than 2,000. The number of known meteorites now is over 50,000. Just explosive growth. So it became an industry in the Sahara. The Bedouin people, the nomadic herdsmen, quickly learned about these strange foreigners driving around, and they started looking for meteorites as they were taking their goats from oasis to oasis. And they would pick up these rocks and bring them to town and sell them. And pretty soon, every Bedouin had his cell phone, and when he would get to the edge of town where he'd begin to get cell service, he'd start to call people and say, hey, I got rocks, you want to buy it? And then you meet at his tent, his little encampment, and exchange rocks. And that still goes on today, except they're becoming more sophisticated. They have X-ray spectroscopes that they have with them now, so they can make sure they're not bringing back a worthless terrestrial rock. They will actually analyze the rock out in the desert and only bring back the good stuff for us. When good rocks fall, you scour an area like this, looking for pieces that are only slightly larger than a grain of sand. But if that grain of sand can go for $1,000 a gram, you find families that have been able to buy homes from a month's worth of meteorite hunting. It's an amazing benefit to the poor nomadic herds. And sometimes meteorites fall freshly in these areas. These people are aware of what to look for. So when there's a fireball in the sky, everyone runs hunting for it. This town is Tisnit in Morocco. And in 2011, this meteorite fell. And it's a meteorite from Mars. It's the newest, freshest Martian meteorite. A group of donors got together and raised the funds for the British Museum of Natural History to buy that rock, and they paid supposedly $1 million for it. So, not a bad find. There are also meteorites from the moon that are found in these deserts. Not all meteorites are ugly. My wife complains that I collect ugly brown, black rocks. Some meteorites are gorgeous. This is called a palisite. It's nickel iron skeleton, and they're olivine crystals embedded in it. And most of us know olivine, are familiar with it as the August birthstone peridot. And this one is sort of an interesting meteorite. Frequently, I've had to travel from my home in Western Mass to the Customs House here in Boston and swear that that rock that I'm getting from wherever it's being shipped to me from is not dangerous. It's not radioactive. It doesn't have germs from outer space. You know, there's a lot of a fear associated with meteorites. We've all seen these science fiction movies, and we know that meteorites are dangerous. This is one of the few meteorites in the world that actually might be dangerous. This one, some of the specimens are radioactive, and sort of a little too radioactive to want around your home. But it's not because of their travels in space, it's because they happen to fall right near Chernobyl. So we Earthlings managed to contaminate these rocks ourselves. And those are, like I said, the only ones that you have to watch out for. And this also makes meteorites look dangerous. This is an Italian magazine cover, or not cover, article about the Holbrook Fall in Arizona in 1912. Now, my wife and I have been lucky enough to go hunt Holbrook, but before we got out there, I had spent decades here in New England hunting meteorites. And in the decades I spent hunting, I found none. We live in a place that has glacial till that brought all sorts of nasty, evil rocks. We have freeze-thaw cycles that break up and rust and destroy the iron-bearing meteorites. We have trees that drop leaves and cover up freshly fallen meteorites. It is just the worst place in the world to go looking for a meteorite. So my wife and I went to Holbrook, Arizona. Notice, no trees, very few rocks, and it's actually relatively warm. There's not a lot of freeze-thaw cycle. So, and we went to a place where meteorites have been found. If you're ever looking for a meteorite, go to some place someone else has found one before. By far the easiest way to find it. And what we do is we look for dark rocks that stand out from the background. They tend to be sort of rounded surfaces from their flight through the atmosphere, and they stick to a strong magnet because most of them have quite a bit of iron. And as we're hunting for these rocks, I found this, and you'll notice I have it labeled Meteoron. It didn't stick to my magnet. And I know that that means it's not going to be one of these Holbrook meteorites, but it looks so much like a meteorite, I had to bend down and pick it up. Yeah, it's a rabbit turd. I was able to tell that it being sort of squishy. Most meteorites are not squishy. But I continued and was able to find my first meteorite ever in the Holbrook strewn field. And my wife too. Less than 2 hours hunting in this known strewn field in the desert, I found a rock, as opposed to 20 years plus in New England not finding anything. So don't look around here. Leave that to me. And speaking of Holbrook, this one is sort of an interesting sample, and I have the jar here with me. These are stolen meteorites. Back maybe, 2010, I'm guessing, there was a break-in at the Lunar Receiving Laboratory, and Dr. Gibson's safe was stolen. And in the safe was some of his personal meteorites, like these collected from Holbrook, some spoiled lunar return samples. Now they're spoiled because they've been taken out of sterile storage for whatever studies. And because of that, once they come back, they're no longer good enough for other scientists to study. The thought of that being spoiled and no good is just beyond me. A piece of rock from the Apollo missions is totally valuable no matter what happened to it. But anyway, they're kept in this little safe. The guy stole the safe, and also in the safe was Dr. Gibson's lab notes for 50 years. Fortunately, they were able to catch the intern who stole the meteorites. They were able to return all the meteorites and lunar samples, but his lab notes were never recovered. The guy who stole it said he never saw them. And so 50 years worth of work gone in one theft. Better, happier story is Richard Kowalski. He works at the Catalina Sky Survey, Mount Lemmon, and outside of Tucson, Arizona. And on October 26th, he discovered an asteroid, TC3 2008. And like any observer, once you finish your observing for the evening, you go home and sleep. And he did that. He went home around dawn, woke up slightly before noon, and was inundated by phone calls, emails, whatever. He had submitted his observing report right here to the Minor Planet Center, and they had computed the orbit for this asteroid and realized it was going to impact the Earth. And not only was it going to impact the Earth, it was going to impact the Earth the next day. So this was the first meteorite ever discovered in space. This is a photo of the smoke trail of it taken by a nomad with his cell phone camera in Sudan. I told you they're all over the place. What happened then was a scientist from Pasadena, the JPL, was interested in, he did orbits and stuff, and he was able to figure out where this meteorite had landed. He hooked up with the University of Khartoum, and they mounted an expedition to the desert of Sudan looking for a meteorite. They managed to take this bus with them, and for those of you who've ever driven through the desert, buses are not the best vehicles. It got stuck supposedly 50 times on the way there, and fortunately the bus was full of young university students who pushed it many times. Whoops, sorry. But what happened was they eventually found the meteorite, and they found hundreds of pieces, very small pieces, most of them smaller than a peanut. And these pieces were of different types of meteorites. We had never seen this before. There were meteorites that were common chondrites, those undifferentiated ones. There were urolites, which were an unusual differentiated one. There were carbonaceous chondrites, all sorts of stuff grouped together in this one fall. So this asteroid probably wasn't a solid rock. It was a pile of rubble that landed in the desert. And if we hadn't seen it in space beforehand, no one would have ever been aware of this type of rock hitting the Earth before or since. February 15th, 2013, there was going to be a near-Earth asteroid flying by with the very romantic name of DA-14 2012. And it was a close pass, 1,700 miles. It would be an easy binocular object at that distance. But what happened was, at that same day, a different asteroid not only flew closer, but entered our atmosphere near the city of
Julius.
Yes. And it broke up in the atmosphere. And when it broke up, there was this huge flash of light. And when you see a flash of light like that out your window, what you do now apparently is you walk to the window to see what's going on. If you're old like me, we learned that when you see a flash of light like that, you don't do that. You duck and cover. And no one did that. No one ducked and covered. People went to the windows to see what was going on. And what happened was the meteorite was breaking up. It damaged 7,000 buildings, some of them relatively severely, and it sent 1,500 people to the hospital. Most of them cut by the windows they were looking out. This is the size of the asteroid that missed us. This is the one that hit us. In this one, we were lucky. This asteroid had been hit in space. It was a shocked asteroid. It had been broken apart and then fused back together. And because of that, it probably wasn't as strong as it was originally. If it had stayed together for even another second longer, it probably would have impacted, and that energy would have been released much closer to the Earth. And instead of sending 1,500 people to the hospital, it might have sent tens of thousands to their graves. And the only thing that was left was this ice crater in Lake Chelyabinsk. It's maybe 20 meters or so across. The next summer, notice how you dress in summer in Chelyabinsk. Divers went and recovered the rock, and it's still in the area in a natural history museum. And unfortunately, after the divers recovered it, they just took it to the museum, didn't do any treatment of it, and it's rusting away now, from what I've heard. Smaller samples were interesting. They hit the snow, and as they hit the snow, they sort of melted it. And then, being cold, that water froze. So there's these impact pits of ice with a meteorite at the end of it. What people would do is to collect them, hunting for them, they'd see this hole. They'd reach in the hole, grab the ice, shake it around, pull it out, and they'd pull out an ice carrot with a meteorite stuck on the end. It's one of the most unusual ways of collecting meteorites ever, and one I would love to have a chance to do, but haven't had that yet. Normally, this would be the end of my presentation, but today is a special day. Does anyone know what happened 210 years ago today? Yeah, you're no meteorite geeks. Sorry. 210 years ago today, a meteorite landed in Weston, Connecticut. And there's a quote that's probably apocryphal from Thomas Jefferson. I would more easily believe that a Yankee professor would lie than that stars would fall from heaven. So, excuse me? Stones, sorry. Sorry, thank you for correcting my quote. So anyway, this quote, which is attributed to him, just doesn't sound like Jefferson. He was a man of science. He would listen to Yankee professors. But this meteorite fell in Western Connecticut. Hundreds of them fell, and it was the birth of the science of meteoritics in the United States. A professor from a upstart university in New Haven went to study them and collected bunches of them, and there's a beautiful collection still in Yale that was originated 210 years ago today. So that's it. Are there any questions? Yes.
The Field Museum in Chicago
Yes.
is a meteorite that went through the roof of a garage, through the roof of a Model T, and ended up in the back seat.
Correct.
They have the meteorite,
They have
the back seat of the car, and the boards from the garage.
Yeah, awesome. There's actually been a bunch of meteorites that have hit cars. That one is Belland, Illinois is the name of that one. There's another one from Colorado. One moving car was hit in St. Louis. But it just shows you how many vehicles there are around. Japan had a car hit also. Yes.
Yes. Having any ideas as to where these meteorites are coming from?
Almost all of them that we have are from the main asteroid belt. Some we've been able to pinpoint to a certain family of asteroids. For example, there's a group called howardites, eucrites, and diogenites that we believe are from the Vesta family of asteroids. I have some meteorites over there that are from the moon or from Mars. So we know some of the specific planet bodies, but most are just unknown main belt asteroids.
Is that determined by spectroscopy for the asteroids?
Yes, exactly. Or is with the moon, sample return, and with Mars, from the landers. Yes.
On average, when a meteorite starts to enter the atmosphere, how big is it then versus how big it becomes after passing through?
Unfortunately, there is no average because different meteorites are made of different materials, but something the size of a basketball might have started out as the size of your desk. So they lose a lot through the atmosphere, but that's just rough guesswork because, like I said, there's so many variables. Yeah.
Excuse me, 3 stories that relate to bright fireballs. I was at a semi-pro football game in Marlboro, Madison one time, and the players were huddling in the middle of the field, and all of a sudden, people on my side of the stadium could see this bright light getting brighter, really blazing, and it just burst into the sparks. Everybody at the same time, like a firework, they went, whoa! I remember the players looking up, what did we do, guys? They thought something was going on in the field.
How long ago was that?
Oh, gosh, back probably 20 years ago.
Okay. I was at the other end of that bright fireball.
Oh.
I did not see anything. I was in Western Mass at Aruna Hill, if you know about that place, with a bunch of other people who are actually meteorite geeks like me. And we heard it. So we were there, I think doing solar observing. And we hear this noise and it's like, what is that? Is that, and then it's like, no, there's no trains, can't be a train wreck. Too loud, lasted too long for a car accident. There are no artillery ranges near us. And we had no idea of what we had heard until we got back into town and were reading about people out here in the eastern part of the state seeing this fireball. And then we realized, wow, if we heard it, it was near us when it was breaking up. Because that's the noise, it's the sonic booms and of the thing slowing down and breaking up. It's going to be, within maybe 20 miles of us. And we spent the next 3 years searching, offering rewards, and it's New England. We didn't find anything.
I have other instances.
Yeah.
This is the reward, pardon my voice here, but of doing star parties. I did a star party for a local school, and after everybody left, I was going to stay around do some observing, and a couple of the custodians came down. And sometimes you feel like you're a little weird being an astronomer talking to them. And I said, what I like about this hobby is you never know what's going to happen. As I said that, I could see my shadow. And I turned around, there's another fireball placed in the air. And another star party, Hale Bopp was in the sky. And I was pointing to some of the parents of the mixed group. And I pointed to Hale Bopp, and as I did, a meteor was blazing across the sky. And I said, how'd you do that?
I have never seen a boloid. It's one of my dreams to see one. I was excited to have heard one. Yeah?
Okay, the French have telescoped their entire country with a network of telescopes and microphones or something to spot incoming stuff.
Yeah, and there's a lot of countries that do it. Australia, the United States, Canada, Germany, Czechoslovakia. And nowadays, we have something even better than that. We have Doppler radar. Doppler radar is designed to detect stuff falling from the sky. This just happens to be rain or snow, but it also detects rocks falling from the sky. So you're able to use raw Doppler radar data to give a good idea of where rocks might be falling. Yeah.
When meteorites fall, is it pretty much a random distribution, or is there one area that gets it more than others?
Totally random. There are many places that are easier to find meteorites, but it's pure luck where they fall. And when I'm hunting rocks, I always go to the places that are easiest to hunt. Deserts, or if it's a place, or if there's, like there was a fall in Wolcott, Connecticut, and I went and was able to find some rocks outside of a house that had been hit. I knew where to look. That house had been hit, the rock broke. I sort of guessed that there must be pieces of it outside. The guy let me hunt, found some pieces of it. Thrilled, excited. First and only meteorite I ever recovered here in New England. But then I went looking for other rocks from that fall. And what I did is I went to parking lots, nice wide open flat places where if there's a rock in the middle of it, I'll see it. You know, I went at dawn, before the malls got filled. You look on nice big flat roofs. I handed out my cards to custodians of greenhouses. You know, hey, does anyone throw a rock through your window? Any vandalism? So you look where it's easiest to find the rock, and then once you find it, you continue to scour around there. But there's no place that's better for meteorites to hit. Yeah.
And speaking of easy places to find them, Ursula Marvin here at the observatory.
Yes.
Probably in the 70s, I think it was. Maybe 80s.
Yeah, maybe even.
Might have been, I don't know.
Yeah.
You know, I'm old, I don't know.
Yeah, Antarctic search for meteorites.
Right. Well, she would go to Antarctica.
Yeah.
And it's the same thing. I mean,
well, Antarctica is different. It's not only do the meteorites stand out on the ice fields, but the ice fields move. They're glaciers. So you have this glacier moving, and then as it's moving, it might hit a mountain peak, and then the ice sublimates, and there'll be a meteorite stranding surface between where the glacier and the mountain meet. So you'll have, you know, 1 million years worth of meteorites that have been brought by this conveyor belt of a glacier right there. So you go and you look there and you find them.
So the wind abrades
yeah.
the snow and the surface. I mean, she had pictures of a lot of them.
Oh yeah, it's amazing. Hey, yeah, it's the best place in the world to find meteorites, just because of you have these stranding surfaces. Any other questions?
All right, Peter. All right,
Thank you.
Thank you. Peter's Meteor Market will be opening, and I just want to say thank you all for coming. I hope you'll have a nice Christmas, happy Hanukkah, and the very best of New Year's, and good health and clear skies to you and me in the coming year. The meeting is adjourned.